Hello, the focus of this video presentation will be on the Eclipse Paho library for Java and its application in building IoT systems. IoT, or the Internet of Things, is a technology that lets electronic devices communicate over the Internet using the MQTT protocol in order to build systems such as smart houses, for example. The protocol requires a message broker and one or more client nodes. One such free message broker is the Eclipse Mosquitto. It's available for all of the most popular platforms, including the Raspberry Pi. I'm running it on 64-bit Windows. Obviously, I already have it installed. It's best to install it as an operating system service and then check in the task manager to make sure that it's running. The IP address of the message broker we can look up using the ipconfig command. On my network, that address is 192.168.1.70 on port 1883. Let's verify that the MQTT broker is running. Let's open two console windows. In one, we will subscribe to listen to all of the MQTT traffic, and in the other one, we'll generate MQTT messages. The T switch is for topic, the pound sign is a wildcard, and the V switch is for verbose output. On the publishing side, the M switch is for messages. And as you can see, the broker works. The hardware client node that I'm using is an Esp8266 module. It's made using the Esp8266 Microcontroller and it's very inexpensive. There are other similar modules like the Sonoff module that are more practical for real projects. Esp8266 microcontroller is designed by Espressif. It's a very capable and fun little microcontroller, however, not sufficiently reliable for industrial applications in my opinion. It's based on the Tensilica Extensa processor. Competing Wi-Fi enabled microcontrollers that are based on ARM Cortex-M architecture have recently become available in the market, but I haven't had a chance yet to try them out. On the Espressif website there are technical documents, SDKs and various tools available for download. For this experiment we'll need the memory flashing tool. I already have it. The firmware that we're going to want to flash into the microcontroller is called ESPEasy. And again, of course, I already have it. For uploading the bare metal firmware onto the microcontroller, I'm using an FTDI USB to serial converter. Make sure you set the voltage to 3.3 volts. On the internet, I've seen recommendations to set the SPI mode to D out. The flash size of 8 megabits is equal to 1 megabyte. I forgot to connect the GPIO 0 pin to ground for flashing. Let's try it again. Okay, I bought two of these Esp-01 modules, one for transmitting and one for receiving, but one of them is busted. It's showing this eFuse error that appears to be quite common with these microcontrollers. For flashing, we'll select the 1024 bytes firmware version and we'll put it at the address of 00000 at the beginning of the flash memory. The second module works fine. I've already flashed it. For deployment, we'll need a 3.3 volt power supply and a switch on the general purpose in-out port, pin number 2. I used a mobile telephone to get the Esp-01 module logged on to the Wi-Fi network. Using the IP address provided at logon, you can access the configuration pages for the Esp-01 module. The name that you set here for the client node will be included in the topic string. Select the OpenHAB MQTT protocol and in the controller IP field enter the IP address for the Mosquitto message broker that we've looked up earlier. On my network that address is 192.168.1.70 and the port number is 1883. Then click submit. On the hardware page you can select the pins for I2C communication. This time we're not gonna need it. On the devices page we're gonna want to set up an input sensor. Let's keep things simple and make it just a simple switch. The name that you set here for the input sensor will also be included in the topic string. Per the schematic that we saw earlier, we'll connect the switch to the GPIO pin 2. The message data format will be simple binary 1 and 0. The name of the value that you set here will also be included in the topic string. In the advanced menu of the tools page, you can adjust the format of both the receiving and the sending topic text string. In this experiment, we're not going to use serial communication, just Wi-Fi. Okay, let's verify if our little client node is working as intended. Let's subscribe to all topics in order to monitor all incoming messages. And then let's toggle the GPIO2 switch on the node. On and off. On and off. Good. The node is correctly sending the topic text string and the payload value. Okay, let's create a new Java project in Eclipse. But not just a regular Java project. Let's create a Maven project. We'll make it a quick start project. And let's give it a meaningful name. Let's call it IoT application. From the project tree, I'm going to delete all of the testing classes. That JUnit stuff is way too complicated for me. I never use it. The library that we're going to use in Java to connect to the Mosquitto message broker is Eclipse Paho. Currently the latest version is 1.2.1. So let's add the Maven dependency to the POM file. I'll delete the JUnit dependency. I'm not going to do any testing. Let's navigate to the Eclipse Paho page in the Maven repository. Let's copy the dependency. And let's paste it in the POM file. I'll adjust the formatting a little, make it look nice. Then hit Ctrl S on the keyboard to save it, and we're done. Now we need to update the project to reflect the changes that we've made to the Maven dependencies. Right-click on the application root folder. It won't fit. Let's scroll down a little. Okay, right-click on the application root folder and select Maven, Update Project. Hit OK. It'll take a moment for the update process to run its course. And we're done. Let's scroll the window back up. And let's open the main application class. I'm going to delete the auto-generated boilerplate code. We'll replace it with something much more interesting. Let's look up the Java doc files to see what methods we have at our disposal in the Paho library. I want to communicate with the message broker in an asynchronous, non-blocking manner. Let's instantiate a new asynchronous client object. We'll call it myClient. Eclipse IDE will automatically provide suggestions on how to fix the errors in syntax. It will automatically take care of all the relevant imports. Let's make this object a field in the main application class. We'll need to provide the MQTT asynchronous client class constructor the IP address of the Mosquitto message broker, and we'll also need to supply it with an IP identifier string for the client. This string can be any unique identifier. I'm going to use a random value. Once again, Eclipse IDE will automatically correct the syntax. Let's correct the declared type of the client object. The correct object type should be MQTT asynchronous client. This field we're going to want to be able to access from another class, so let's make it public. And that other class is the Callback class. Let's create it. The callback class will implement the MQTT callback interface. There are probably better, more elegant ways to do this, by using a lambda expression or by passing an interface as an object, but I'm not a professional programmer and that stuff is way too complicated for me. I'll just stick to the mechanism that I can understand and that makes sense to me. So I'll create a callback class that implements the MQTT callback interface. There are three methods that we're going to have to create because they're mandated by the callback interface, but that's a good thing because we'll need those methods. Then we'll create an instance of the callback object. Let's call it myCallback. And then let's link that callback to the MQTT client that we created earlier. Now we can establish a connection to the Mosquitto message broker. We chose to use the asynchronous, non-blocking method of communication with the message broker, but we want the connect method to block. We want communication to wait until connection is successfully established. Next, we'll have myClient subscribe to the topic that the ESP01 microcontroller node is set up to publish to. I could have just copied this string from the console. For the purposes of this exercise, I don't really care about data integrity. The lowest level of the quality of service is fine. I'll set the quality of service to 0. Alright, let's compile and see if it works. I don't have any launch configurations yet. Fine, it compiles and runs. Cool, let's add some functionality to the message arrived method and see if we're receiving any messages from the microcontroller node. Let's print all received messages to the system console. The first argument passed to the message arrived method is the topic, and the second argument is the message. What am I doing wrong here? Oh, right, you use the plus sign to concatenate strings. Great, let's save everything and run it. It runs, that's a good sign. And when we flick the switch connected to the GPIO 2 pin of the microcontroller node, we're getting input. Messages are coming in. Let's compare that input to the messages being published by the microcontroller node. Great, we have a match. Okay, the messages are coming in nicely, but the purpose of this application is not to simply print those received messages out to the system console. We want our application to act on those inputs and to provide directives to other client nodes. So let's go ahead and publish this data. Same as before, we'll set the quality of service to 0. Let's save our changes. One thing that you don't want to do is to publish to the same topic that you're subscribed to, because that'll create an infinite loop. So let's create a new topic. We'll copy the format of the topic that we're subscribed to, but we'll change it. We'll publish to a topic that's addressed to a different client, client 2. And the device that we publish to will have an output switch, like relay perhaps. Let's save it all again. And let's see what happens when we toggle the GPIO2 input switch on and off. First, we'll toggle the input switch on and off while the Java application is not running. We can see messages coming in from the ESP01 module, and there is no other activity. Now let's start the Java application. Look, we're processing the input received from the ESP01 and we're publishing it to another client node, to another topic, to client 2 that has an output switch. Since my other hardware node is faulty and we cannot use it to receive this published data, let's make a virtual software node for that. To accomplish this, let's use Node-RED. I already have it installed on my computer. The graphical user interface is accessible in a web browser. Just HTTP to the local host address shown in the console. Here it is. Let's set it up. We want our node read client to receive MQTT input that's being published by the Java application. Let's enter the IP address of the Mosquitto message broker. And the topic that our Java application is publishing to. We can just copy and paste without the quotation marks. Again, let's set the quality of service to 0. And then let's add a debug node that will allow us to monitor this MQTT traffic. We need to give it a name. We can imagine something like the SON-OFF module with a relay switch built in. Let's deploy this setup. And then let's view the MQTT traffic in the debug window. Once again, let's flick the input switch on and off repeatedly. Beautiful. Let's clear the debug window and do it again. It works perfectly. Thank you for watching this video. I hope that it'll inspire you to make your own IoT projects in Java.